Okay, so what we're going to do today in about the 40 minutes we have left is talk about naming compounds. So this again, I'm going to record this and post it, so I know you guys might be a little tired. Or thinking about the test, I understand that. Okay, so here's the first thing that you always have to do when you name compounds. You have to identify it as one of the two types. Now, we talked about ionic compounds, right? How do you know an ionic compound? Metal and a non-metal. And for everything else, we call them molecular compounds or covalent compounds, okay? So we're going to name them differently whether or not they are ionic or the other one, okay? Covalent or molecular, yeah. Okay, and you also have to recognize there are going to be some common names that you just need to know, like water is H2O, and ammonia, which you see all over the place in household cleaners and stuff, and fertilizers, you see ammonia all the time. So first thing you have to do is identify the type of compound. Okay, when you name an ionic compound, and that's what we're going to handle first, okay? You have a metal and a non-metal, and when you name it, you name the metal, you name the non-metal, and then you put it together. So like my son, James, right? James is his metal name, and Calgoa is his non-metal name, and his whole name together is just James Calgoa. You just shove them together to get his name. Okay, so it's the same thing with compounds. It's just like your name, you have a first name and a last name. Ionic compounds have first names and last names. Okay. The one weirdo that you'll see is NH4. And remember, ionic compound stands for it's made up of ions. Okay, so NH4 is ammonium ion. You should know that, actually. Let me write that down. The reason it's the weirdo is because it's all nonmetals. And normally the cation, when we deal with it, is a metal and it's easy to name. But it's a nonmetal. So you'll see it in something like this. It's a very common compound. And so even though that's all nonmetals, it has ions in it, so we have to name it as an ionic compound. Okay.
Which means you put the plus on.
Yeah, and that's why that's...
When you put the two ions together, one's plus, one's negative,
that cancels out. Yeah. So you have to have, that's why if you see that plus up there, that's the ion.
And that makes it unusual.
Yeah, because it's all nonmetals, but it's still an ion. Okay. So let's just talk about the first name, the name of the metal, okay? So in ionic compounds, there's the name of the metal. There's metals that form only one type of ion, and we've already talked about those. I'm going to gloss over it a little bit, but if you remember, if it's group 1, 1A, okay, what's the charge of everything in group 1A? It's 1. Okay, so that's what I mean. There's some metals that only form one type, and they actually, there's a name for those. They call them the type 1s because it makes one type. So I'll often refer to it as type 1. And then there's other metals. Oh, sorry, group 1A. Let me fill that chart out for you. 2A, 3A, 3B. And then zinc, silver, and cadmium. And for all of those, you can predict its charge based on which group it's in. Now, I don't like this periodic table because it doesn't show the Roman numeral groups up here, but this is group 1B, and this is group 2B, even though they're at the end. I know it sounds weird. Because this makes +1 and this makes +2. That's a simple way to think about it. And then these make +3. Okay, so it kind of got that way just because of things like that, yeah. Okay, so these make +2 ions, these make +1 ions. The periodic table that I gave you on the exam, and you can all have a copy of that. I could put it on Blackboard for you or whatever. That has those Roman numerals in it so you can remember, okay? All right, so those are all the fixed or type 1. Now, some metals form more than one type of ion, okay? So like iron, for example. Iron can make 2+, or iron can make 3+. In the name, the only way to know that is to either figure it out from the compound or I tell you. Okay?
In other words, if there were two chlorines, then that's the plus, goes with the plus
So
two.
yeah, if I had 2 chlorines, or if I combine these with chloride, is what it's called,
Yes.
this would be Fe2+, so Cl's each 1-, and so you would have 2 of them with this one. You would have 3 of them with this one.
There's one of your indicators.
What's that?
That's one of your indicators.
Yeah, it's one of your indicators. That's by getting it from the formula.
Yes.
Yeah. Okay, so how do you know which ones are type 2? This is one of those stupid questions. Because it's not in the others. It's not type 1. So you have to know these, right, before you can identify these. This is relatively easy if you can remember 1, 2, and 3, right? 8, and then also 3B, and then zinc, silver, and cadmium. On the periodic table, the way they look is it makes a triangle. So here's 3A here. Makes a triangle like this in here. And those are all the fixed, okay? If you actually look on, oh, it's not the slide. This slide here, these are all the, what I'm talking about right now is just the cations, and these are generally known as the monatomic cations because they come as one atom ions. But aluminum, gallium, indium, this one is copper, silver, and cadmium. Copper? Yeah, no, zinc, silver, and cadmium, sorry. My finger, brain, didn't connect. All right, so that's the fixed charge monatomic. Now, just a little side note, and I'll spend some time on this later maybe. These are the fixed charged monatomic anions. They're -1, -2, sorry, -1, -2, -3, going that way like we did from the periodic table last week. So if I said carbon as a monatomic anion and you wanted to know what its charge was, you would just start here and go 1, 2, 3, 4, it's 4-. Okay? So all these make only one type of ion, one charge ion. Okay. All right, I disconnected, so I'm going to just go with what I have. It's the internet died. Oh, never mind. Oh, and here's a table. You don't have to memorize this. This will give you a table of a bunch of different cations that you can form. So it's like mercury can make a 1 and a 2. Lead can make a 2 and a 4. So there's all kinds that you could have. The way you figure it out, like Wayne was talking about, is from the chemical formula. You don't have to memorize all these, okay? You'll get it from a chemical formula. Let me see what slides it skipped over. It's really slow, the internet. Okay. I don't know what it's doing. Okay, so let's just focus on, I'm just going to make up my own notes now. We're going to focus on type 1 metal. Compounds. And I'm going to focus on things like, let's do sodium and chlorine. Okay. So for sodium, this is just sodium. Now this is chlorine, the monatomic anion. So this becomes chlorine, get rid of the Ne and make it chloride. And all the monatomic anions end in IDE. Okay? So this is sodium chloride. That's the name. Again, common name for that is table salt. That's what you get to eat every day, or not eat every day, depending on what your blood pressure is. But yeah. Actually, do eat a lot of it even when you have high blood pressure.
It's in everything.
It's kind of in everything. You can't avoid sodium. Yeah, so if you're going to eat sodium. You just have to eat less. Right? Thanks for some. Oh, so by the way, the sign-in sheet is going around. Just put your name in it. That's all. Initial it. That's all I need to know. And don't forget to turn in your homework. Yeah, it's kind of weird. It's kind of working, kind of not working. So I'm just going to record what I say and then write on the board, and then when it catches up. Okay, let's do this one. So what's BA? Barium. Good. Okay, so silly thing. Is that 2 R's or 1? It doesn't matter.
It's a neon one here.
What's the? Oh yeah. Well, what's this ion? What's this element? Sulfur, right? So what does it become? It becomes sulfide. Okay? Get rid of those last 2 letters and go sulfide. So the name for this is just barium sulfide.
Why did it become sulfide instead of sulfate?
Oh, because it's monatomic. So let me write this out, because this is an important thing to recognize. So sulfur can be like that as a monatomic ion. It could be SO3 2 minus, and it could be SO4 2 minus. This one ends in IDE, this one ends in ITE, and this one ends in ATE. So the way you tell if it has oxygen on it, it doesn't end in IDE. The way you tell how many oxygens it has is whether or not it's an 8 or an 9. Okay. So that's actually something people miss a lot, but they don't recognize. IDE, it's just a monatomic. Okay. Okay, so let's do this one. Let's do come on, we'll do aluminum. AlCl3.
See, that shows you.
Okay. So, again, this is type 1, so I don't have to worry about anything else. This is chlorine, right? Ignore the subscript for now. That's chlorine, so this becomes aluminum. And then this is chlorine, so it becomes chloride. Just like that. So then the question is, why don't you tell people how many chlorines there are? And the answer is because it comes from the charge. Since aluminum always is a 3+, and chloride is always a 1-, there is only one combination that it makes. So we don't say aluminum trichloride because they figure it out from the charges. The assumption is, right, you're talking to a chemist or somebody in this class. You know, you may, if you have like your grandmother and you're trying to explain to her which aluminum compound to buy, you might tell her. If you told my mom, she would know because she was in chemistry. Long story. It's genetic. Okay, so the question. Okay.
Senior moment.
Hey, you know, we all have those, and we're not. I'm going to guess that some of us are a little older than others. You and me weigh, and I think we're on the same side of the hill. By the way, it goes uphill after a while again, too. Just certainly. You get rid of your kids, we have life. No, kidding. All right. So that's how you name type 1s. Type 1s are really easy. Now, you also have to do with polyatomic ions. So remember we had sulfate and sulfite, right? So sulfate, I'm just going to use these as an example, sulfite. I taught you how to name these last week. This is SO4 2 minus. This is SO3 2 minus. So when you see something like this, it's an A. You can name that. This is type 1, right? Calcium. It's in the first or second group. So this is calcium. Just write the name. What's that? Sulfate, right? So you would just write sulfate. So type 1s are really easy to name because all you have to do is look at the metal, the non-metal that's with it, and name both. Okay. Now let's go the other way. This is always a little bit more confusing. We're going to do barium. It's 1.
Yeah,
It's 1 on it.
yeah.
Yeah, I spelled it with 2 the last time.
Yeah, it
Looked
looked a little
funny.
weird.
Looked a little weird, and I decided to try it a different way.
Yeah, that looks better.
That looks better. Okay, so barium oxide. Okay, now you have to figure out what the formula is, because you got to be able to do it both ways. Okay? So now I'm going to go both ways on this thing, and it says, what's barium's charge?
Plus
Barium, and well, it's a type 1, you know that, so you can look on the periodic table,
2.
and it's plus 2, way at the bottom. So barium 2 plus, like that. And oxide is what? Well, oxygen, right? Now that's a monatomic anion. I know it's monatomic because how do I know it's monatomic? Ends in IDE, so I just look at the periodic table, go -1, -2. So right off the periodic table, I get a minus 2. Okay, so, hang on. Okay, so how many of these do I need for every one of these? 1 and 1. So this is just D, A, O. And there you have it.
I know what it was. If, you know, they balance like that. If they didn't, and you had like 1 oxygen with 2 bariums, it would be reactive, and it would look for something else in order to cancel out the charges until it was stable.
Yes.
That's what I was.
I'll tell you guys what he said in a second. It was a good point, though. Well, the premise of what we're doing is all compounds are electrically neutral. That means the pluses add up to the minuses and the compound gets together, and that's stable. Okay? But if you put, for example, barium ion with phosphate ion, and you did 1 and 1, right? What would happen? There would be a 3 negative, a 2 plus, there'd be a negative charge, and that would attract positive charges, so it would pick up another barium. And it would just do that until eventually it canceled out. So, long and the short is, the charge of the positives has to be the charge of the negatives. So I have 1 barium here, 1 phosphate here. Now, you already know the name of the compound, barium phosphate, because it's type 1. Okay? What's the formula? Well, you go like this, barium, there's a 2 here, and a 3 there, right? Ignoring the signs, you just cross multiply. So you go 3, and then PO4, 2. And then those charges will cancel out. Just to show that's true, though, let's write it out. I have barium, 2 plus, barium, that's what the 2 plus, and barium, 2 plus. That's what that 3 means, right? There's 3 of them. And then there's phosphate, PO4, 3 minus, PO4, 3 minus. What's the total positive charge?
6.
2, 4, 6. What's the total negative charge? 3 and 3 is minus 6, right? So that's the reason for doing that, is so the charges come out to be the same, and that's what represents the stable compound. Okay. All right, so that's... You want more practice? Yeah, let's do... somebody pick your favorite metal. What? Zinc? What's her? Bismuth. Okay, bismuth. Is bismuth really your favorite?
Is that how you say that?
Really? Crazy. Bismuth.
I always like the I don't know why.
I don't even know how I can spell it. Bis.
M-U-T-H.
M-U-T-H, yeah.
M-B-I-S-M-U-T. Anyway, let's do bismuth. Okay, so I'm going to tell you it's +3. Okay, so I'm going to write it like this, and oxide. Okay, it's not one of the type 1s, but we're going to do it anyways, since it's her favorite. She really, actually, it is her favorite, so what am I to say? So bismuth 3 oxide, this number means the charge. So we're kind of skipping into type 2s, okay? So this is going to be bismuth, Bi. Charge is 3 plus, because that's what I told you. Oxide is what? O2 minus from the periodic table. IDE means it's monatomic. You just go straight to the periodic table again.
We're back to that.
Okay, so now, if it's bismuth 3 oxide, then how many bismuthuses do I need for every oxide? Right? I need 2 of these for every 3 of those.
Again, the cross multiply trick.
Again, I'm taking this number, bringing it down here, this number, bring it down here. They call it the crossing rule. I don't even know if that's an official name, but that's what we call it. So. Okay, so writing formulas from names is fairly easy. As long as you can interpret the name, you know the charges, and you just put them together. Okay, let's do, so let's get back in line where we were. Let's start with type 2s now. Type 2 metals. So again, type 2 metals, it's the same format. First name, last name. Okay. First name, for example, let's do manganese. Now, it turns out manganese comes in different flavors, okay? And so the 2 flavors, if they're not up here, are one in, well, actually it comes in 7 flavors.
Oh, really?
Yeah, it comes in a whole bunch. So I have to tell you which one. It's kind of like George Foreman and his kids. Do you guys know about George Foreman, the boxer? He's got a bunch of boys, right? And he's got some girls. What does he name them all? George. How does he know the difference? They have numbers, like George 1, George 2. Right. So this is like George Foreman's kids, except there's only 7 of these. I think George Foreman has more kids. So how do I know which manganese it is? I have to tell you. Okay? My kids have numbers too, because people lose track. So they're like, oh, James, which one is he? Oh, he's number 1. Or Andrew, oh, which one is he? He's number 7. Or 6, sorry. It seems like 7. He's 6 and 7 combined, let me tell you. He's a handful. You learn all these tricks to take care of discipline your kids and keep them on task, but somehow they always don't work really the way they did with the last one. Zach, this is like Zach, this is manganese 2, like this. Okay? So this is actually the charge. So we're going to do manganese 2 chloride, or let's do iodide. Okay. Iodide, what is that, monatomic or polyatomic? Monatomic, because it ends in IDE. Right? Okay, so that's IDE. So that just means it's I. So what is I's charge? Look at it on the periodic table, right? Monatomic anion, periodic table, -1. Okay. So this is I minus. Manganese is 2 plus, so it's Mn2 plus, and now you can write the formula. So how many I's need to go with Mn? 2, so this is MnI2. Now, here's the thing. If I'd given this to you, you could have worked your way backwards and figured out the name. Because you would have said, oh, it's manganese. I don't know which one, but I know I have 2 iodines.
There it is.
So this, you would say to yourself, that's -1 times 2, right? So that means that has to be +2, because it has to add up to be 0. So this has to be 2 plus from the name. So you can actually, from a formula, figure out what the name of the cation is, and the anion names don't vary. They're always the same. The IDEs always have the same charge. The 8s and the ions always have their same charges, okay? So let's do another one. This time I'll give you a formula, and then we'll have to figure out what the name is. So, FeO, again, we're not doing type 1. How do I know that Fe is not type 1? Because it's not type 1. You memorize type 1s, and it's not one of the ones you memorize. So yeah, it's and especially because it's in the middle of the periodic table, those are all type 2s. All the transition metals, except for the few that I pointed out, are type 2s. So then you have to say, well, I want to know what this one's name is. But how do I know what this one's name is? I have to look at the oxygen.
That's right.
So oxygen comes from which group, right? So over here, I need to know its charge. So I'm going to go this way, -1, -2. Okay, so I know that oxygen oxide here is -2. So what does that mean the iron has to be? +1. +2? +2. Sorry. Did I say +1? I did. Whew. Man, I tell you. So the name of this compound is iron, and because it's a type 2, I have to put the charge in parentheses, 2. That's a Roman numeral, oxide.
Now, is it that did they call it like iron, they call ferrous and ferric?
Yeah, so let me talk about that a little bit, because I'm doing the next one. Okay, let's say I have Fe2O3. I got to name that one. Right? So this is a little trickier. I don't know the name of this one, but I know that this is oxide. Now don't worry about this subscript 3. It got the 3 because you needed 3 of them to balance the charge. Okay. You want the easy way or the hard way? Easy way, right? Then I'll show you how it works. That's the hard way. How it works. The easy way. Remember we did the crossing rule, right? And we did the crossing rule. That's where these subscripts came from, right? So what is this iron? What's the charge of iron here? It's got to be 3 because that's how it got. That's how that 3 got there. And I know this oxide is -2, so I knew that was -2 already. Just to do a double check, though, right? 3 times -2 is 6, minus 2 times +3 is 6 plus. And this is the charge of oxygen, so that works out. So that's the easy way. It's called the uncrossing rule. So if you cross it together, you can uncross it to get what the charges are. Doesn't work 100% of the time, but that's why you check to make sure it adds up okay. So then what happens is, I can name this. This is iron in Roman numerals. 3 looks like that, and then oxide. Iron 3 oxide. This is the principal component of the thermite. You want to do thermite? Yeah, we'll probably do thermite. I just haven't had a chance to ask the lab tech yet. This is actually a laxative. Kind of different, huh? Stool softener is what they call it. Don't even want to think about it. Okay, so now this is a 3+ ion, and this is a 2+ ion. It turns out historically, this has also been called ferric. And this one's been called ferrous. So this is also known, this is ferric oxide. This is known as ferrous oxide. Okay. I don't ask you to memorize too many of those, but that is one of the ones you need to know. Just ferrous and ferric. And this is strict memorization. It's ferrous is +2 and ferric is +3.
It seems like the ick is the highest number. And
Yeah, ick is usually the higher number. But that number
isn't always 1 and 2,
is not always 1 or 2.
or even consecutive, 2 and 4.
You know what that is? It's a stupid way for you to remember. It's a Ferris wheel.
Oh.
You know what you do with chemists when you can't cure them? You bury them. Actually, there's an element called curium too. So when you can't curium, you bury them. Oh my gosh! You want to know the one about why we like nitrates so much? I'm just erasing, killing some time. Okay, so that's how you do the metals, right? Ionic metal, non-metal compounds. So that's how we do all ionic compounds. Type 1s, you don't have to write the charge. Type 2s, you have to write the charge. In type 2s, you always figure out. In type 2s, you always figure out the charge from the formula. Okay. You look at who it's with, figure out what it's like.
Company.
Yeah. I often refer to it as like a dating relationship.
Yeah.
Okay. So that's ionic compounds. Ionic compounds type 1, type 2. Then we do what we call molecular or covalent compounds, and there's 2 sets of rules for these. I'm calling it both of these names, even though your book only calls them one of them, I think, because this is how you're going to see it later. You'll recognize them later based on these names. Okay? So molecular or covalent compounds, non-metals, non-metal compounds. And we are only learning the binary compounds. Okay? What does binary mean? 2, right? So there's 2 elements in the formula. So I'm going to teach you, here we go, M-O-N-O. What does mono mean? 1, di, tri, tetra, penta. Let's see, hexa, 6, hepta, 7. In the old days, when somebody was hep, they were cool. He's so hep. Hep, sorry. Octa, more TMI. 8. Nona, I know somebody with that name. 9, Japanese, it's a Japanese first name. N-O-N-A. And deca, that's 10. That's probably good enough for memorization purposes. Okay. So there's 2 kinds of binaries. This one is H as first element. And this is acids. So I'm going to do a whole bunch of stuff over here. So this is covalent or molecular. And then everything else. I'll just do it that way. So let's do it like this. S2O5. You want to name that. Okay? In all of these names, now you know this is binary, but there's like actually 7 atoms. Binary just means 2 kinds, not just 2 atoms. Okay? This is so easy. How many sulfurs are there? So you would say di-sulfur. You notice that's the full name. And then it would be pent. Now, you can either leave the A in or kill the A. A lot of times when there's 2 vowels together, they'll get rid of the vowel in the prefix. Okay? it's about 50-50 on this one. It's mostly about how it's pronounced. Okay, so this is disulfur pentoxide. So you notice what I did, I put the IDE ending on here, and I just wrote the name of the first. So the reason it's easy is you just need to know the prefixes and names of the elements. The last one always ends in IDE. Let's do P2O3. So this is what? Phosphorus. How many are there? So you go diphosphorus. And this is tri-3, right? Trioxide. Now, going the other way is really easy because it's actually, if you needed to do the name from this, all you do is say, oh, there's 2 phosphoruses and 3 oxygen, and you just write it. Okay. So I'm not going to spend any more time on that, but there's going to be homework problems on that. You practice them. If you have trouble with it, ask me questions. But usually I lecture too long on that, and people just hate me for it. Okay, so I don't know if hate might be too strong of a word. It might not be, but it could be. Okay. So now, what if there's an H in the front? 5 more minutes, guys. I do know when the class actually ends. I just don't like always ending at the end. So let's say it's HCl, okay? So this is molecular, so you could actually name it as hydrogen chloride. Oh, I did leave one thing out. I'll have to go back and tell you about in a second, but I'll do that later. Or you could name it as an acid. If it has a hydrogen as the first element, this is as an acid. Okay? So it turns out acids, like you hear, not acid like LSD acid, but acid like swimming pool acid, those all have hydrogen in their formula as the first element listed. Okay? So this is actually muriatic acid. It's the stuff that goes in swimming pools at very high concentration that burns your eyes when you pour it in. It's also what is found in murine, the eye drops. The concentration is just way lower. Okay, so don't think, oh, look, I got swimming pool acid. We put that in my eye. That'd be like a really bad idea. But it's same stuff, murine, muriatic acid, swimming pool acid. All right, so how do I name it? Depends on the suffix, but for now we're going to do with IDE. So IDE, I'm going to replace it with ic. And then you put at the front of it hydro. So it's going to be hydro something ic, and then the word acid. So this one I always pick because people sometimes, well, a lot of people know this one is hydrochloric acid. Okay. What's this one?
Either way is correct, though. So you could say hydrogen chloride or...
Yeah, so this is the name as an acid. This is just its molecular name. Yeah, so either one's correct. Usually if they're looking for the name as an acid, it says something like this, HCl and then AQ, meaning it's dissolved in water. So they're asking about its behavior when it's in water. AQ means aqueous or aqueous. Okay, what about HBr? What would you call HBr based on that? Hydrobromic acid. Yeah. What's the hydro mean? It means the hydrogen bromic acid. Well, that's an easy way to remember it. Okay. Now, there's a lot of other acids. So let's take HClO3 and HClO2. Naming acids is about identifying what the name of the anion is. So I know this is chloride, so that's how I named this. Okay. This those are polyatomic ions. So these are not necessarily binary, but it's how we get there. And it's, the naming rules are still the same. If I cover that up like that, all right, just like put my hand over that, that's chlor-8 and that's chlorite. Okay, so we're going to write this out. We're going to write chlorate. And this is chlorite. Now, the monatomic, the chloride, you put hydro in the front. With these ones, we never use hydro. Okay? So, this is chlorate. This becomes chloric in the name, which is confusing, right? Because it's the same as this one, as the monatomic, but we don't put hydro in the front, and that's what makes it different. Okay? This is chlorate, and so it becomes chloric, and this is chlorite, and this becomes chlorus. So this part stays the same, and you have different suffixes at the end. Okay? And the name of this as an acid would just be chloric acid, and the name of this one would be chlorus acid. So I'll make a little table to summarize the ics, the ites, the us's, the hydros, all that stuff. Okay?
So is it like hydrogen chlorate?
Nope, you leave the hydrogen on. Oh, as a molecular, if you're naming it as a compound, you would say hydrogen chloride. But as an acid, you name it as the chloric or chlorus. Okay. So acid names go like this. You look at the suffix for the anion, and I'm going to start with IDE because that's the monatomic. I'm going to go ITE and ATE because there's like chlorate and chloride, all right? So this is what you do. You put hydro, name of the element that's in there, like chlorine becomes chlor, and you end it in ic. So that's what we did over here. Hydrochloric acid, hydrobromic acid. Hydroxide acid, it's H2O. It's water. Hydroxide acid. Anyways, that's how it would be named. ITE, right? Ite goes to be, let's do it like this. Something OUS. And 8 becomes it. Now, one thing that people have memorized is the white mouse ate icky cheese. Ite goes with us, 8 goes with ick. So those go together and those go together. Okay? So that's just one of those handy dandy, if you need to memorize it, memorize it. Alright, that covers everything except for chemical formula weights. I think that's the last question on the homework or something. But I'll still post this